Now let's talk about some exponential rules. What are those derivative exponential rules? Look, if I have a function in this form x to the 2, it equals to 2 times x to the 2 minus 1. It is pretty clear from here that I can apply a simple power rule because I have a variable to the constant. So just apply the power rule. Derivative of x squared is 2 times x to the 2 minus 1. But what if I have constant to the variable, which is 2 to the x? It equals to 2 to the x times natural log of 2. Look, the difference is the base and the exponent. Here the base is x and the exponent is a constant number. So I'm going to apply the power rule, but here the case is different. My base is constant and my exponent is a variable. So the derivative of 2 to the x will be 2 to the x times natural log of 2. It is the rule, it is the exponential rule. If you have a function in such form, remember for the natural log of 2, whatever base you have, you're going to put it here. If it is 3 to the x, you're going to put natural log of 3. If it is 5 to the x, you're going to put natural log of 5. Look, I applied this rule, a to the x equals to a to the x times the derivative of x times natural log of a. How I got this expression? This expression is according to this rule. If you have a constant to the variable form for the function, if your exponential function is in this form, its derivative will be a to the x, put a to the x as it is, and then times the derivative of x. So derivative of x is 1, and then natural log of a. Whatever base you have, you're going to put it here. It is actually 2 to the x times the derivative of x. So the derivative of x is 1, and then natural log of 2. Since the derivative of x is 1, therefore I didn't mention 1 here, but actually it is 2 to the x times 1 times natural log of 2, which is based on this formula. But what if I have x to the e? It equals to e to the x to the e minus 1. Now look at here. If your exponential function is in this form, variable to the e, here e behaves as a constant. If you remember, we have mentioned in the natural logarithmic functions that base e is a specific constant number. So here e is a constant. It is exactly like this one, x to the 2. Apply the same power rule here as I applied here, which was 2 times x to the 2 minus 1. We apply the same rule here because e behaves as a constant. It is a variable to the constant. So simply apply the power rule here. X to the e is e times x to the e minus 1. For the 2, I have e here. Nothing is different here from this one. Just apply that power rule x to the n, which is n times x to the n minus 1. But what if I have pi to the e? It equals to 0. Look, the pi, which is the base, is a constant, and e, which is the exponent, is also the constant. So when you have the case where you have constant to the constant, your derivative will be 0. So derivative of any constant is 0. Look, this case is different from here. Here I have base in a constant form, but my exponent is a variable. Therefore, it equals to 2 to the x times natural log 2. But here, the exponent is a constant. It is not a variable. E is not a variable. E is a constant. So derivative of constant to the constant will be 0. So there were some derivative exponential rules that you must keep in your mind. Let me show you some more exponential rules. If you have only e, f of x equals to e, derivative of e is 0. As I said previously that e is a constant number. It is a specific constant number, so derivative of any constant will be 0. Therefore, derivative of e is 0 if you have only e. But what if I have e to the x? It equals to e to the x. Derivative of e to the x is e to the x. It is according to this rule, e to the x equals to e to the x times 1 times natural log of e, which is actually this rule, a to the u equals to a to the u times u prime times natural log of a. Look, what is different here from this one? It is a simple e, which is a constant. So derivative of a constant, which is e, is 0. But here its exponent is a variable. It is e to the x. Base is a constant, which is e, and exponent is a variable, which is x. So derivative of e to the x is e to the x. But it is according to this rule. Derivative of e to the x equals to e to the x. Put e to the x as it is, and then times, don't forget to take the derivative of x. So derivative of x is 1, therefore times 1 times natural log of e. Whatever base you have here, put it in front of the natural log of e. But since natural log of e equals to 1, so you will have e to the x times 1, which is ultimately e to the x. Therefore, we simply put that the derivative of e to the x is e to the x. We don't mention this part because ultimately it equals to e to the x. It is only possible when the maximum power of your exponent variable is only 1. If it is x squared, then the case is different. How? If I have e to the x squared, I will have e to the x squared times the derivative of x squared. So derivative of x squared will be 2x, and then times natural log of e. But since the maximum power of this x is 1, therefore the derivative of e to the x is e to the x, which is according to this rule. If your base is a constant and your exponent is a variable, you are taking the derivative. It will be a to the u times derivative of u times natural log of a. Just apply that rule if your function is in this form, constant to the variable. But what if I have e to the 2? Derivative of e to the 2 is 0. As I mentioned many times that e is not a variable, it is a specific constant number. So when you have the case where you have a constant to the constant, my base is a constant, my exponent is a constant. So derivative of constant to the constant will be 0. Derivative of e to the 2 will be 0. Because when you apply this rule, e to the 2, derivative of e to the 2 is e to the 2 times 0 times natural log of e. My exponent is a constant number, which is 2. So just apply that rule. For the x I have 2. So derivative of e to the 2 will be e to the 2 times the derivative of 2. 2 is a constant, so derivative of any constant is a 0. Therefore derivative of 2 will be 0. I will have e to the 2 times 0 times natural log of e. So the product of 0 with anything will be 0. Therefore derivative of e to the 2 is 0, based on this exponential rule. If my function is e times x, it equals to e. Because look, e is a constant number and x is a variable. So it is like constant times a variable. So derivative of e to the x is e. It is exactly like 2x. So derivative of 2x will be 2. Derivative of 3x will be 3. Therefore derivative of e times x will be e. It is a constant. Just apply the power rule here. If I have x to the e, it equals to e times x to the e minus 1. I just did this, that derivative of x to the e is e times x to the e minus 1. It is a variable to the constant. When you compare this part with e to the x, it is different because here the base is constant, exponent is a variable. Here the base is a variable and exponent is a constant. It is exactly like x squared or x cubed. It is a constant number. So just simply apply the power rule. X to the e is e times x to the e minus 1.